We have a 6 kilogram block. It's sitting on a ramp that's angled at 35 degrees. And our job is to figure out what the normal force and force of friction acting on this ramp happen to be. First thing we always want to do is draw all of our arrows, all of our pictures, the forces that we've got on here. And we've got force of gravity parallel that pulls down the hill. The normal force is perpendicular, going upward. The force of friction pulls back into the left, trying to stop this block from sliding. And the force of gravity perpendicular is the force that pushes into the hill. So from our picture, we write our equations. After we figure out, well, which way is my positive direction and which one is my negative. I'm going to say down the hill to the right is positive, up the hill left is negative, up that way is positive, and down into the ramp is negative. Now we can write our equations. The first one I'm going to do in the x direction. So I'm going to take my positive force, which is the force of gravity parallel. I'm out of positive forces, so I go to my negative force, which would be the force of friction. That's why it's minus, because it's in the negative direction. I'm out of forces that go left and right, and I know this object is not accelerating, so that means it's just going to equal 0. From here, I can solve for force of friction with a little bit of algebra, and I get that the force of gravity parallel has to equal my force of friction. The forces are balanced. And I have an equation for force of gravity parallel. My equation for force of gravity parallel is the sine of the angle, which is 35 degrees, multiplied by the mass, 6 kilograms, times 9.8 meters per second squared. And that is going to equal my force of friction. I plug that into my calculator, and I should get 33.7 newtons for friction. Now I'm halfway done. I'm going to solve for the normal force now. I do the exact same thing, just in the y direction now. I'm going to take a look at what are my positive forces, and I know that my normal force is in the positive direction. I'm out of positive forces, so I go to the negative direction, and I have force of gravity perpendicular. And all that stuff, when I add it up, is going to equal 0 because this object is not accelerating. With a little bit of algebra, I can solve for my normal force. Normal force has to equal the force of gravity perpendicular. We have an equation for the force of gravity perpendicular, and that would be the cosine of my angle, which is still 35 degrees, multiplied by the mass, which is 6 kilograms, times the acceleration due to gravity, 9.8 meters per second squared. And I plug that into my calculator, and I should get 48.2 newtons. And we're finished.